Good evening.
Good evening, sir.
Start. Okay, so today we'll be going through this knife base and SVM classifier. Okay, again, it's the same process that we described before. You have a synthetic binary classification dataset, you do the train test split, use a knife base classifier. This is the class for the classifier, knife base classifier. Train the classifier using the fit function, get predictions, calculate accuracy score. I mean, these are additional plotting boundaries. Okay. This. Okay. This is the data set. This is the decision boundary. Accuracy is actually 90%. Okay. And it is really good. There are some points here and there. I mean, I think it should be fine. It's not a big deal. It's 90% accuracy is there. So the model is really good here. This is how you train an I-based classifier. Okay. And same thing, same data set, you can use the SVM classifier. Okay. For that, you use the SVC class, train, get predictions, calculate accuracy, and then you can also plot the decision boundary. Okay. The ones in sort of red and blue with black border that you see, right? Those are actually your support vectors. As you can see, these are on the line. There is something here, there is something here. Okay. And I mean, and you might also notice there is a point that's going through the hyperplane margin, but SVM uses something called kernel functions that will lift these to a higher dimensional space. I mean, you don't need to worry about all those, but this is essentially what you need to know. There are support vectors. This is the optimal hyperplane, and the accuracy on the test set is 95%. Okay, got it. And if you want to increase the performance further, you can do the hyperparameter search. Okay, how do you do? You define a parameter grid, which is a dictionary containing the hyperparameters values like C, gamma, and kernel. Along with it, you give these some choices. Okay, C from 0.1 to 1000, gamma from 1 to 0.001. You can have different kernels like linear, RBF kernels, and so on. These are different hyperparameter choices. Okay. Instantiate the grid, put the classifier, also this the parameter grid, give it as input. Make sure refit is true because at each iteration, the model needs to retrain the model again and again. Okay, it should initialize it newly and retrain it again and again. And the CV here stands for cross validation. Okay, if you look at the parameters estimator, there is the parameter grid, some scoring, which is accuracy. Okay, and you can also pass in the number of folds. I think there should be some argument where you can also pass the CV score. You can pass in the CV split. Okay, here I'm mentioning CV equal to 5. So it's a 5-fold cross validation. Okay, you fit it, get the best parameters, and your all the model is already best model is already stored in this, so you can all actually get predictions. and you can print the accuracy score. Okay. Once all this is done, you see the accuracy is 100%. The increase from 95 to 100%. So that is really good. So for the initial thing, what I want you all to do is, again, instead of 100 samples, take 10,000 samples. Okay. Same, train the Gaussian naive Bayes, see the decision boundary. Same SVM. You don't need to change anything. Get the predictions. Get me the accuracy score. And also for the hyperparameter search, I suggest you add extra values for C and gamma. Okay. Kernel you don't need to change. Try to put some extra values for C and gamma. Also change it to 10-fold cross validation instead of 5. Okay. I'll share this now. You all can go through the notebook and try it for yourself. Okay. And let me know what's the best accuracy score you all got. Okay. Putting it in the chat box. If you have any doubts, you can ask me. But I suggest you all change the data set, run the different models, also change the hyperparameters that you need to tune in GridSearch CV. And yeah, let me know the results. That you're able to actually improve the model performance or not for support recognition. Okay.
No doubt, sir.
I no, you all have to try it and let me know what the answer is. I put the notebook in the chat box. Ten thousand samples, and you have to change the hyperparameters also. And in addition to all these changes, let me know what the precision recall F1 and RSA score is for. I need to know all the metrics, the evaluation metrics for both naive Bayes and SVM. Okay. So calculate all this, and if someone is done, let me know the answer. Okay? You don't need to change much. You just have to change the code in some places. Like here, instead of accuracy score, you can calculate precision recall, ROCAOC, and yeah. Someone can also plot the confusion matrix and see how it is. Okay. It's simple, so let me know once anyone's done. I hope you all have your laptop also with you.
Sir, for the first cell, what we can change now, sir?
First,
The first cell is Gaussian. What I change?
no, you just have to change the number of samples in the data set and also calculate different
Okay, sir.
metrics.
Okay, And now I change the sample as n equal to 1000, sir.
Okay. What
Then
is
the
the
output
accuracy?
will show. So accuracy is 0.86, sir.
Okay. What's the precision, recall, and F1 scores?
The precision is 0.76
Okay.
and got recall is 0.87, sir.
Okay. F1 score?
So F1 score is 0.74, sir.
Okay. Do this. Can you tell me the same for SVM?
Okay, sir, I will try.
Okay. Anyone got any answers for SVM?
So 0.93, sir.
Okay. Same, you can calculate other metrics. Now moving to this grid search. I want you all to put CV as 10-fold cross validation, and also add some extra values. Whatever you think it's good enough, add one or two values to C, one or two values to gamma, and let me know what's the final accuracy score. Okay.
Okay, sir.
This is how you should do hyperparameter tuning. Okay.
Sir, I got 360 fits.
It's okay. What's the final accuracy? It should be there at the end. And let me know the best number of best parameters also. What was the accuracy?
Sir, still the value is loading, sir.
Okay. Okay. Yeah. Then I shall start sharing the next screen.
Okay, sir. Sir, I got SVM accuracy as 0.94, sir.
Okay, yeah, that's really good. That is how you train models, do hyperparameter training and everything. Now we'll start with decision trees.
Okay, sir.
You have to install a bunch of packages. Okay, so this is how you install some packages. You start with exclamation mark, like pip install panda, scikit-learn, graphis, mtlearn, and so on. Okay, you start with loading necessary packages. Okay, for decision trees, and this is a data set. Okay, that you can create. Okay, do you think this data set can be easily separated by a model? Oh, it can be done. So you draw a line like this, like this, like this. You keep drawing lines and end it here. Okay, that will be a good decision boundary. Let's see how a decision boundary is built for this data set. Okay, so first you ask this question. Okay, if x is less than or equal to 0.06. So somewhere around here, you draw a line. That's what you do. You have rows as 2, 32, and like if it's false, you have 48 yes and 18 no's sort of thing. Do you think this node is pure? What does it mean to be a pure node? Pure node means it should only be zeros, like it should be 0, 34 or 48, 0. There should be 1, 0 in the counts. Okay, then it's a pure node. Then you can stop there. Since it's not pure, you go again. You ask one more question. Okay, you do separation one like this, one like this. Okay, like two values. Is there any pure node here? Can you check? How many pure nodes are here? Okay, I can zoom in a little. Yeah.
2, sir.
Yeah, there are two pure nodes. So this side, you don't need to ask any more question. Okay, you can just leave it like that. You can focus only this side. Okay, and slowly, okay, this is depth 2, and you keep expanding this again and again. This is sort of the decision boundary that you have. Okay, this is how a decision tree is built. You keep asking a bunch of questions, then you stop when one of the both some leaf nodes are pure. If it's still impure, you keep asking questions again and again. In this row, how many pure nodes are there? There is one pure node. Okay, that's it. And
Yes.
but the problem is how many questions you can ask. Can you just keep asking questions and going on? No, right? Because it will be computationally very difficult. Okay, and there is problem of overfitting also, because this triangle might actually be a blue circle that might not be labeled properly and so on. So you have to be careful when to stop. And that is again a hyperparameter, the depth. Okay. So I have loaded the best concept data set. It has 516 examples, 30 features. Okay. And these are the feature names that you have. Okay. I'm splitting the data and I'm drawing a decision tree classifier. Let's see the default parameters. Default parameters, the depth features is none because it will take everything. Here there is no depth of the tree. Yeah, max depth. Okay, that is the max depth. So you can set the max depth so that you only ask 4 questions. Here you don't set any depth. You see the performance. Here it's overfitting because it's 100% training set accuracy and 91 test. If you limit the maximum depth to 4, you see, okay, training accuracy decreases a little bit, but test accuracy is increasing. So this is more preferable. You don't need to ask 1,000 questions and get 100% training set accuracy. What you are really interested in is the test accuracy. So when I give this notebook, you can keep changing max depth and see how the test set accuracy also increases. Okay, that is there. Then again, this is the decision tree for the breast cancer case. Okay, you can see how big the tree is. You can count the number of pure nodes and pure nodes. There are some impure nodes where you stop, but most of them are pure nodes, okay, at depth 4. One more thing you can do is also get feature importance. What I mean by feature importance is that given just this, let's say this worst compactness feature alone, can I separate both the classes? Okay. So this is how you get feature importance. Like there is an attribute that you have here from the decision tree. Okay. And you can plot it like this. The most important feature is worst radius. Let's say if a feature importance is 0, like mean symmetry, mean congruence, these are all 0, okay, or very low. You can drop those features. Just consider these features alone. Your model will still perform better. Okay. Here again you have a confusion matrix. Okay. Same thing that we have discussed before. But can we increase the test accuracy further? And that is where we saw we can use the random forest classifier, right? I'm creating some data set, synthetic data set here. This is called the moons data set because this is a half moon here, there's a half moon here. You want to separate it. Same in the random forest. You can see like how each tree works in a forest. This is one tree, this one tree, this one tree. There are like 5 different trees. What random forest will do is it will merge everything at the end. So sort of like do majority voting, and you see, is this better than this one? Is random forest better than tree 4? Is it having a good enough separation?
Yes, sir.
Yeah, see, there is one specific line here that's not desirable, but mostly it's good. It's going smooth. It's able to trace the shape of the data set. Okay. I'm using the same in cancer data, but in this case, all the features are important. Okay. Decision tree, only some features are important. Here, all the features are important. So you can keep all the features for random forest. And accuracy here is also 97.2 on the test set, and it's really good. Okay. This is the confusion matrix that you have here. And so what I want you all to do, this is sort of a homework. Okay, I'll ask the answer tomorrow. I want you all to tune the hyperparameters for random classifier. Okay, see if you can get better than 97.2. If someone gets better accuracy than 97.2, let me know what all different combinations you try. Same grid search CV that you have here. Okay. Here you have to replace it with random forest. Here parameters you have to look. It can be max depth, n estimators, so on and so on. You do that and make the samples as 10,000. Okay. Try it. Let me know what the accuracy is before tuning and after tuning. Okay. And I'll just share the notebook now. You all can start trying. Okay. I'll put it in the chat. Source. I run everything. First decision tree, change the depth and see how the performance is changing. And I want you all to implement the hyperparameter search also. Any doubts in these two notebooks?
Sir, on decision tree, you say make depth, sir. That is a question.
Number
How
of
many questions?
questions. Yes.
Okay,
How
sir.
many questions? Yeah. Same max depth you can set for random forest also, but there you can also input how many trees you want. That is the n estimators. Okay.
Okay, sir.
Any other questions?
Sir, on SVM output, how the data will split
SVM here.
output, sir? CV,
Uh, there. This one.
yes, sir.
So you can think each of these
Yes,
as
sir, as based
in
on the C value.
oh C value you're saying. Okay. C value
Yes,
you don't need to worry about that because that you need to know about optimization and so on. Okay. You just think of it as a hyperparameter that needs to be tuned for now.
okay,
Because
sir.
for you to know the importance of C, gamma, and everything, we need to mathematically derive the optimization that's involved in SVM and so on. And I feel that is sort of like out of scope for this course because if you keep discussing every mathematical formulation, it's basically a machine learning course that will take for months. And this is sort of like a basic introduction to machine learning where you can suppose a new data set comes to you, you can run any model that you all that that I've taught in these tutorials and so on. Do a little bit of hyperparameter tuning and get the best possible score. Okay? That's the objective of this course.
Okay, sir.
Okay, I've shared the notebook. You all can start trying. And if there are, so I'll ask. Okay, I'll ask someone what's the output. Okay, what's the best possible accuracy? So everyone has to answer like what's the best possible accuracy they got. Okay? And what's the hyperparameter combination also. That's a thing that you have to do. And if there are no doubts, we can end the session for today. And next we'll be starting with unsupervised learning. Okay, this is another thing. So yeah. Well, thank you.
Thank you, sir.
Thank you, sir.
Thank you.